Hello. Big data analytics is the future. Big data analytics can help you to optimize your decision making and stay a step ahead of the competition. This video is about the descriptive analytics part of big data analytics. Let us start with asking ourselves, what is descriptive analytics? Well, descriptive analytics can be considered as the conventional form of BI, business intelligence, and data analysis. It seeks to provide a representation, a picture, or a summary view of facts and figures in an understandable format. So descriptive analytics presents past data in an easily digestible format for the benefit of a wide business audience. In this video, I will go back to the basics so we can be sure that every one of us has the same definition of technical words that we are using in big data and data analytics. So let us start with a quick example. For example, if you have two groups, each group is composed of 13 students. And based on the results of the IQ test, for example, let's see these two results. Which group do you think is smarter? The class A or class B? Each individual may be different. And if you try to understand a group by remembering the qualities of each member, you become overwhelmed and fail to understand the group. Some of you will say B is better than A, for example. But if we summarize everything in a mean, for example, in the means of each group, now, which group is smarter, do you think? Well, you see that they are the same. So with a summary descriptive statistics, it's much easier to answer our questions. Descriptive analytics takes massive amount of historical data and turns it into digestible information. It's the process of interpreting what's happened in the past while mining two types of data: quantitative data and qualitative data. Quantitative data is composed of numbers, tests, counting, measures, while qualitative data is composed of words, images, observations, videos, conversations. Categorical data can be nominal or ordinal. Nominal data can be measured if each category is mutually exclusive. It means each observation cannot fall into more than one category. Example, men, women. The measurement needs also to be exhaustive. It means that the system of categories should have enough categories for all the observations. Ordinal data works with the same assumptions as nominal data, but is more complex. In this case, the categories themselves are rank ordered. One category has more or less of some underlying quality that being in another category. What does this mean? If we take, for example, statistical judgment about the relative position of one value to another and we can perform with this case limited mathematical calculations. Numerical data can be composed of two parts: interval and ratio. Both interval and ratio data are examples of scale data. It means that data is numeric format, $50, $100, $150, and can be measured on a continuous scale. So the scale is continuous. Data can be placed in a rank order, and the distance between each can be observed and as a result measured. It can be measured. So interval data are ordinal data, but with constant differences between observations. Example, time, for example. Time moves along a continuous measure or seconds. Seconds, minutes, hours, days, and without a 0 point of time. Temperature moves along a continuous measure of degree and without it to 0. Ratio data are measured on a continuous scale, but they have a natural 0 point. Example, monthly sales. Another example, the weight. age. In a purchase order, for example, the supplier name and number, the order number, are examples of categorical data. The cost and the quality are ratio, and the quantity, sorry. The date of delivery is an interval. If there was filled column for supplier rating, for example, excellent, good, acceptable, or bad, that data will be ordinal data. A common business question that can be answered using descriptive analytics is, for example, how much did this customer segment spend during a given period? Or what promotion did this customer segment engage with? A common example of descriptive analytics are company reports that simply provide a historical view of organization operation, sales, finance, customers, and stakeholders. A common application of descriptive analytics will summarize past events such as regional sales, customers order, percentage of discount given per zone, and other examples. It either informs or prepares data for future analysis. Descriptive analytics is mainly based on exploratory data analysis, known as EDA, and descriptive statistics. Let us remember together what's exploratory data analysis. EDA. Exploratory data analysis is one of the most important and overlooked part of descriptive analytics. It was developed by John Tukey. The exploratory data analysis aims to explore a data set using methods that help you understanding the data, to help you understanding the events that generated the data, to help you seeing what happened, sometimes in spite of your expectations. For example, if we have sales per day of work per salesman as follows, for example, Bob, 10 days of work, 100 sales. Carol, 15 days of work, 150 sales. Dave, 12 days of work, 120 sales. Anne, 17 days of work, 170 sales. Steve, 13 days of sales, 95 sales. Steve is clearly an outlier. Most EDA, check, this is Steve, he is an outlier. So we were able to identify him. Most EDA techniques are graphical in nature, with a few quantitative techniques. The reason for the heavy reliance on graphics is that by its very nature, the main role of EDA is to open-mindedly explore data. Graphic gives the analysis unparalleled power to do so, enticing the data to reveal its structural secrets and being always ready to gain some new, often unexpected insights into the data. This is the aim of descriptive analytics. Most descriptive analytics are based on descriptive statistics. Descriptive statistics explore the location or the center of the data, measures of this is important, the idea of location, the mean. It organizes data in tables and graphs. It analyzes how do the data vary. So it measures the variability by summarizing data and computing the central tendency and the variation. That was about exploratory data analytics. Thank you.